It's going to be pretty soon that I'm going to be seeing you guys every day, almost every day. Let's talk about that, actually. Not that much bigger, because for my B-Day class, I have you guys Wednesday, Thursday. The Thursday class only has 3 or 4 people in it. Yeah. No. I'm not talking about the future. I'm talking about today. I'm not talking about what's going to happen in a few weeks. I'm talking about the current schedule. Oh, no. That's not what I'm talking about. I'll cover that in a moment. But let's just say you guys are my Wednesday kids. My Thursday kids for period 3B, there's only 3 or 4 kids there. So that's just an additional 3 or 4 kids to the room. That's not that bad. I got you. It's going to be a little crazy for some other classes, like my AP Stat class. I have 25 kids. Yeah, it's going to be pretty insane. No, mind you, some of them are virtual. Maybe like 8 or 9 of them are virtual. So I'm still going to have a good number of kids in the class. Yeah, okay. You know, it's going to be pretty chaotic. But that's actually what I wanted to talk about. First thing I wanted to talk about, for those of you who are live, because I actually do have some people live, and I'm pointing at you right now. I wanted to talk about the calendar. Now, first of all, here we are, Wednesday, October 21st. Next week is a full week. Still have you. Fantastic. What's going on this week? You're not here. You have the week off. You have the election. Follow me on YouTube. I'm going to be live streaming the election night, like 5 or 6 hours. Nice. It's going to be awesome. Dude, you should see the spreadsheets that I have. I'm going to show them. I'm going to do like a preemptive video, kind of be like, here are my predictions. And I'm going to post my predictions so that people can't say that I faked it. You know what I'm saying? So it's like, hey, look, I posted this like October, whatever. And now here's November 3rd, the election. Shut up. Anyway, back to this. This week, you're back. It's still the first marking period. I want to be clear about this. This is still the first marking period. This week is the second marking period. And this week, starting November 16th, I believe is when they're instituting that everyday thing. I want you guys to be aware of that.
So the start of the second marking period
every day. Yeah. Now, somebody asked me earlier today, Mr. Markey, are we coming back where it's like AA and BB, and then is it going to be AB? Like, how is that going to work? To which I looked at them and I went, because I don't know. I don't think they know either. Now, there's a TV show, and I'll give you this example because I've told it to every class. There's this TV show that I don't watch. I have never seen this TV show. I've only seen like a clip, okay? It's on Netflix. It's called Schitt's Creek. I've never watched it. No offense. I've never watched it. People tell me that, that it's very funny. But there's a scene that I've seen where this guy is like cooking something, and there's this woman giving him directions. And she's like telling him to do this, and he does it, do this, and he does it. And then she's like, okay, and the next step is fold in the cheese. And he's like, what do you mean fold in the cheese? And she's like, you just fold in the cheese. And he's like, I know what you said. It's just that, how do you do it? And she's like, you just fold in the cheese. And he's like, saying it again doesn't help. Like, how do you fold it? And they get this huge argument about folding in the cheese. The reason why that's the only clip that I've seen is because, well, think back to the beginning of the year, school year, I should say. They're like, okay, teachers, you're going to go back and you're going to have some kids virtual. You're going to have kids in class, blah, blah, blah. Okay, how is that going to work? Just don't worry about it. It's just going to work. You're going to live stream it, and then it's going to be great. You're going to have virtual, and you're going to do hybrid. Okay, how are we doing hybrid? You just do hybrid. Just fold in the cheese. What the heck does that mean? So then we're coming back 5 days a week. Okay, how is that going to work? Just you're coming back 5 days a week. Okay, but how is that going to look? Just 5 days a week. You'll be fine.
So like for the first week, you don't know how exactly you're doing that.
I mostly don't even know what I'm doing every day. Most of the stuff that I teach you is completely made up, and you guys wouldn't know the difference, would you? No. You're going to find out next year. Oh man, Mr. Murky taught us all fake stuff. Yep, and nobody knew. I just make it up as I go along. Yeah, but yeah, that's going to be the schedule for the next few weeks. Okay, next. Hey, remember in September when I gave you guys like a benchmark to do? And I was like, hey guys, do this benchmark. And then I was like, hey guys, this benchmark, we told our supervisor, hey, the information on this benchmark is not correct. And she's like, no, do the benchmark. And we're like, no, but the information is not correct. The information on the benchmark that you're telling us to assign is based on stuff at the end of Algebra 2. We can't give them this benchmark. Just give them the benchmark. Okay, but just give them the benchmark. Okay, but it's wrong. 2 weeks later. Hey, guys, we found out that you gave them the wrong benchmark for some reason. We don't know how this happened. You mean the benchmark that we told you was wrong? Okay, all that to say, you have to do the benchmark this week. Yes, you do. Now, I'm going to be very clear. It does not count against you. It's an ungraded thing. But your scores, which are not going to count against your grade, they are not counting against your grade. Those scores will be recorded and they will be inputted, but they will not count against your grade. But they will be inputted and they will be analyzed by my supervisor. So I do need you to get those things done. The information on the benchmark is what you should have taken 3 weeks ago. But again, fold in the cheese. It's going to be on geometry information. So information from last year, they're trying to see how much you have retained. Oh, happy day. What a day to be alive. What a day to be alive. I'm excited though, because I talked about my dad earlier with you guys about how much of a steel trap he has for baseball. I'm going to be interviewing him on Saturday during Game 4 of the World Series. I'm going to be interviewing him for my math of sports class because my dad has a wealth of baseball knowledge in his head, just like off the top of his head. He remembers like the day of the week and the weather when he went to like a certain game. Did I mention like about Jackie Robinson? He legitimately saw Jackie Robinson play. How many people can say that? Not that many. Alive. Babe Ruth died in 1948. My dad was 9 years old. He could have seen him. Yeah, that's true. But Babe Ruth retired in 1935. Yeah. Anyway, fun fact about Babe Ruth. You know, the first 5 years of his career, he was a pitcher. Yeah. For the Boston Red Sox. Yeah. Oh, yeah? Nice. Fun fact about Babe Ruth that you're not going to get from Sandlot. Babe Ruth once started a game as a pitcher for the Red Sox in the 1910s. He walked the first batter. He got upset at the umpire and proceeded to have a conversation with him that ended with Babe Ruth punching at the umpire. Babe Ruth got ejected from the game. The next pitcher came in. The batter who was at first, because he walked, tried to steal second and got thrown out. Out number 1. The pitcher who came in to relieve Babe Ruth proceeded to retire the next 26 batters in a row. Yeah. It's not exactly a perfect game, but it's the closest thing you're going to get. Okay. I'm going to pass something out to you. Ladies and gentlemen, we are nearing the end of the unit on quadratics. We're nearing the end of the unit on quadratics. Now, that is not to say that we are done with quadratics. What I mean by that is this. This first unit that we've covered has been on quadratics, second-degree polynomials, parabolas. The next unit is going to be dealing with higher-level polynomials, cubics and quartics and quintics, in which factoring and solving will still be a thing that you have to do. Factoring and quad formula are still things that you are going to need in the next unit. Just to be clear about that. But we are wrapping up the unit on quadratics. Now, in terms of your projects, I am still in the middle of grading them. I'm submitting them as I'm grading them. So some of you may have your grades, but some of you don't as well. So I am grading them as soon as I possibly can. But now here's the big headline of the day. Next week, I do plan on having an assessment in regards to quadratics. I do plan on having a major assessment in regards to quadratics to wrap up this unit. So I will have those projects back to you. I will have appropriate feedback. Obviously, you're going to be working on various things for me, but next week is going to be that assessment. And then we're all going to high-five each other at a distance and then move on to the next unit, which will still use this information. Oh, it's going to be great. It's going to be grand. I don't know. Let me give you this. Now, what I'm passing out, for those of you in the chat, I'm passing out a worksheet. Now, I'm going to post this worksheet in a few minutes to the Google Classroom stream. so that they can have it too. There's 2 in there. Yeah, 2 So I'm going to post this in a minute to the Google Classroom stream. But this is my goal of the day. My goal of the day is to, number 1, work on this worksheet. And number 2, take a very brief set of notes to kind of wrap up what we need. Now, what I'm doing right now, I am going to input that worksheet that I was referring to. There it is. Into the Google Classroom PDF for the day. Post. There it is. Good. So the PDF for the day, if you are in the live stream, there is a PDF that I just posted, and this is the worksheet that I will be working off of. So if you need to see it, you'll see it. Otherwise, I'm going to ask the rest of you guys, we're going to draw a lot on this particular worksheet today. We're going to draw a lot on it today. So let's see what we got. First, if I'm going to bring this thing up, you and your friend are playing tennis. Now, I may not play tennis, but I know quite a bit about tennis in regards to the history of it and how it's played and champions and things of that nature. But tennis is not one of those things that I play regularly. I think I have a tennis ball in here, actually. Here we go. I do have a tennis ball. I also have a baseball and a lacrosse ball. I don't know why, but I do have a tennis ball. So we'll talk about that. I'll leave these here. Lacrosse balls are weird. They're like very dense rubber. Anyone ever get hit by one? No? Okay. For later. Anyway, to this. So we're playing tennis. You and your friend are playing tennis. Your friend lobs the ball into the air. Haha, like that. Great. Hitting the ball 3 feet above the court. Now, what the heck does that mean? It means something like this. He lobs the ball. And then pretend it's my tennis racket. And he goes, like that, and hits it across. Here we go. Woohoo! I'll do it again. Ready? So again, when I say 3 feet above the court, something like that. He's kind of underhand smacking it over to you. So maybe he'll lobs the ball in the air and then goes, heads up! Can you believe they let me do this job? Yeah. What? Oh, they don't even know I'm here. Huh? Maybe. We'll see. Anyway, there we go. There's a lot of dents up there, just so you know, but that's from me. Now back to this. An initial velocity of 40 feet per second, you back up and prepare to hit an overhead smash to win the point. There's a lot of information in there. 40 feet per second, 3 feet above the court, all of these numbers. But basically, I'm going to demonstrate just visually what that looks like, and we're going to draw a picture. So again, your friend's over here. I'm not going to do it this time. And boom, they hit the ball. And the ball goes in whatever path it goes into, parabolic path, waiting for you on the other side of the court. And you're waiting for the ball to come back to here. Now, you're preparing to smash it. You back up and prepare to hit an overhead smash that's just basically like that to win the point. That's what you're trying to do. Let's draw out what this looks like so that we have a frame of reference. Let's bring that here. So at the top of your page, I'm going to ask you to draw the following. At the top of your page, draw a little XY plane going on here. That's a terrible straight line. Whatever. And here's the ball initially. Here's the ball at 3 feet. Zoom in a little. And your friend hits the ball. Now the ball has to travel across the court. And if you know anything about projectile motion is in the path of a parabola. It is a parabola that is facing downwards. And this is exactly what we've been dealing with for the past month. And now here are you on the other side of the court. And you have your tennis racket. And you are preparing to hit an overhead smash. And it looks something like that. Oh, hold on 1 second. Now it looks like me. It's got a little beard. But this is the situation that we're faced with. Now, clearly, if I'm preparing to hit an overhead smash, the ball is much higher than 3 feet. I don't know exactly how much it is, but we'll deal with it when the time comes. Because if I'm doing an overhead smash, something like this, I see me in the chat, there you are. If I'm doing an overhead smash like that, clearly I'm not down here doing a 3 feet off the ground overhead smash, but we'll figure this junk out. Let's see what the first question has in store for us, because this is our frame of reference. Now, mind you, I'm going to keep coming back to this picture, and I'm going to keep adding things to this picture. Part A. Use the model. That's when most people turned off their brains. I'm not even kidding. That's when most people really do that. They look at this and they're immediately like, nope, next problem. No. Oh, who's saying hi? Ah, he likes the physical and physical, I can't even talk today, explanation. But now, again, most people look at this and they're like, nah, I don't get it. Well, you don't get it because you're not reading it. No, Mr. Markey, I read it. No, you didn't read it. Most high school students hate word problems. They do. My job is to get you past that. You have a phobia. The phobia comes from the idea, and I don't know where most of y'all got this from, but you look at a math problem and you stare at it and you hope that if you stare at it long enough, the answer will just make itself obvious. You do. I told you my sandbox example. Yeah. The idea of like you look at a sandbox, there's a quarter on top, you take the quarter because it's yours. But then if there's a quarter buried, it's like, hold on, I got it. Didn't work. Because you got to dig. You got to dig. You got to exert some mental awareness in this. Let's just read and see what happens. There's this model. Ugh, it looks terrible. But they tell you V sub 0 is the initial velocity. Oh, I've heard that phrase before. Initial velocity. Huh, interesting. And H sub 0 is the initial height. Now, they didn't use the phrase initial height, but based on what we drew, because I like drawing pictures, it looks like the ball starts its path 3 feet above the ground, according to what the problem was worded as. Now, you have to use the model to write an equation giving the height of a lobbed ball as a function of time. Let me underline a few things here. Let's see. First and foremost, I'm going to underline initial velocity of 40. It says feet per second. Those are units that we're somewhat familiar with. Initial velocity is V sub 0. Okay. And then 3 feet above the court is when the ball starts its path. That would be the initial height. This is the answer to part A. Negative 16t squared plus 40t plus 3. Now, a couple things to that. First and foremost, Mr. Markey, where'd the little 0 go? Well, the little 0 was a part of the variable. If you notice when I read that, it was V sub 0. You guys have dealt with subscripts before. Do you know the most commonplace area that you've dealt with subscripts has been with the formula to calculate slope? How do you calculate the slope of a line? I didn't teach you Algebra 1, so I don't know. That is the equation of a linear. But what is the formula for calculating the slope? That would be the whole this thing. These are little subscripts. The 1s and 2s are subscripts. That's what this thing is up here. It's a part of the variable. It's just a part of the variable. Nothing to be alarmed about. The little sub 0 is where you start. But this is the equation. This is not the only way you can write the equation. I need you to be familiar with this. There's another way to write that equation. The other way to write that equation is like this. By the way, my little tail, my cute little tail at the bottom of the T's, I just do that so they don't get confused with plus signs. I like doing it. It's just a habit. But anyway, back to this. What the heck is that? Now, you've seen this before, just maybe not in those letters. You have seen this before. That is nothing more than f of x. You've dealt with f of x, function notation. You have seen f of x before, whether it be in Algebra 1 or geometry, or when you closed your eyes during math class. But f of x is nothing more than, oh, I input a number for x, there's a calculation, and something happens. Just like I plug in a number for t, whatever number I plug in for t goes in here, and I make a calculation. Question. If the ball is standing at 3 feet above the ground right here, how much time has gone by in our function? If I go back to my picture even, hold on, woo, I'm gonna fall, there we go. If I fell, people would have laughed. Most laughs I got all day. Anyway, if the ball is right here at 3 feet, let's say my friend has not hit it yet. How much time has gone by? 0 what? 0 seconds, yeah. 0 seconds. Now let me go to this. If I plug in a 0 right here for time, 0 seconds, that means that I also plug in a 0 here and I plug in a 0 here. H of 0 is equal to what according to this calculation? What does this calculate to become? Yeah, no, what? Sorry, I was anticipating and I jumped ahead of myself. It's 3 though, right? This is function notation. 0 seconds is the input, 3 feet is the output. That is just function notation. That's all that it is. I just need you to be familiar with it because you might see stuff presented like that. You might see stuff presented like that, and I just want you to be aware of it. All right. Now, we've talked a little bit about units. You talked about seconds. You talked about feet. Let me put some labels on my graph. Hold on. Let me go back to this picture. Zooming in, zooming in, zooming in, zooming in. Woo! Seconds. Feet. You ever try to write sideways? It's very difficult to write sideways. I'm just putting some units on there, or some, units, just because I need to know what this is. The x-axis here is measured in seconds. That's your t. And your y-axis is measured in feet. That's your h. People are typically hoping for x and y, but you're not always going to get x and y. All right, let's go to part B. Part B. What is the average rate of change of the height over the first 2 seconds after the ball was hit? Average rate of change. Here's the other reason why people hate word problems. When high school students do word problems, they expect that word problems will be able to be solved in the same way that they've done other problems. They don't like it when they see a problem where you have to improvise or alternate what you do or do something that you haven't been used to in the past 5 seconds. Most high school students just learn a topic, that's enough for the chapter, and then they forget it. I'm trying to get you to remember things that you've learned in the past and apply it to current problems. Word problems, you have to look in your toolbox and you have to see what do you have in reserve to attack this problem. Now, I've underlined the phrase average rate of change. What the heck does that mean? Aside from all of this, don't worry about parabolas and tennis balls and your friend with it doesn't matter. What the heck is average rate of change and where have I heard that before? Ooh, rate of change. I don't know who taught you Algebra 1. When did y'all take Algebra 1? 9th grade? Yeah. So it was like 2 years ago for some of you, 3 years ago, doesn't matter, whatever. It's been a while. It's been a minute. Is what? I'm sorry. I miss Houlihan. You know why Houlihan had to leave? His wife worked at the power plant on Lacey Road. No, not Lacey Road, Route 9 in Lacey. and shut down. So his wife lost her job. And she had, with her field of expertise, she got another job down in Maryland. And her job can only be done in very specific locations, whereas he's a teacher, he could teach anywhere. You know? So, unfortunately, that's why we lost Houlihan. That was a huge loss, though. I'm still crying over that loss because he's a good guy. But back to this. Rate of change. Rate of change is nothing more than slope. Slope. That's all that it is. Slope. Wait, you didn't get a teacher for the entire rest of the year?
For like the middle, it was really weird.
So who came in near the end?
South, but she was only here for like the last 2 months.
Gotcha. Fun fact. Mrs. South was my 11th grade AP statistics teacher at Southern. Yeah. She'll never let me forget it. Anyway, back to this. This is slope. That's all that it is. It's slope. I wrote it on the board before. Y2 minus Y1 over X2 minus X1. We need to calculate slope. That's what they're really asking of us. Rate of change is nothing more than slope. That's what it is. Change of Y over change of X. Ugh. What is the, now I'm going to replace the words. What is the slope of the height over the first 2 seconds after the ball was hit? In order to calculate slope, what do you need? What do you actually need to use this formula? Say again? An X and a Y. A point, or more specifically 2 points, as he just said. Well, we have 1 point. I know what 1 point is. We did this one earlier. 0,3. We know that. 0 seconds, 3 feet. It says that it wants the height over the first 2 seconds. So the next one that I got to do is got to be 2 comma something. How do I get that? 2 comma something. How do I get the something? Ugh. Again, this is something where the word problem is not going to just spoon feed you the information. Where? That we had in part A. Yeah. This is what I'm saying. The problem's not going to spoon feed you the answer. Yeah, you got to dig a little bit. So we got to plug that 2 in and see what we get. Oh, go to my calculator. The calculator usually knows what to do. Well, the calculator only knows what to do as long as you type it in correctly. Boom, 19. Now, what that means is that when the ball is hit 2 seconds after it's hit, the ball is 19 feet in the air. 2 seconds after it's hit, the ball is 19 feet in the air. All right, I can do that. Now I got to calculate this junk. First of all, we got 19 minus 3. Hey, 19 and 3, remind me, what are they measured in, these two numbers? In the context of the problem? Say again? Feet. They're measured in feet. Now, that's important. That's important to recognize in a few moments. And on the bottom, these two numbers, 2 and 0, what are they measured in? Seconds. Again, very important to recognize because I'm about to do something nuts here. This becomes 16 over 2, which just becomes 8. Now, you just told me the top of the fraction was measured in feet, and you said the bottom of the fraction was measured in seconds, which means this 8 is not just an 8. This is 8 feet per seconds. It's a velocity. It's a velocity. It's a speed. It's a rate of change. This is the average velocity of the height of the ball after it has been hit. Maybe. I don't know. See, because the thing is, it's like the ball's clearly doing something like that. That's what it is doing. But I don't know where this point is. Let's just say it's like here, right? This is 2, 19, and this is 0, 3. And we're just like, okay, what's the average rate of change over that span? The average rate of change is 8 feet per second. Because if you think about it, like, how many seconds have gone by? Just 2 seconds. So if it's 8 feet per second, it goes from 3 to 11 to 19. But clearly that's not what the ball is actually doing. The ball is following this curved path, but they did want the average rate of change, which by definition is slope. It's crazy. A little velocity thing going on there. Now, clearly the ball is not going to continue going up 8 feet per second over the course of time. What will the ball do over the course of time? It'll come back down. It'll come back down at some point, which begs the question, will the ball ever reach a height of 30 feet? We don't know at the moment. We don't know at the moment. The ball will go up until it reaches a certain point, and then it'll come back down. But that certain point, that apex, has a very special name. A name for which maybe I've referenced, but I've never actually talked about in great detail. Something that you may have seen in Algebra 1, but you vaguely remember because it was 2 years ago. Or Houlihan had to break my heart and leave. Stupid Houlihan. I should text him again. Anyway, he actually just won our fantasy baseball league. I have to get him the trophy. I told him he has to come up here and get it. Anyway, will the ball ever reach a height of 30 feet? And then they ask why. Let's find out. Do you guys know what that point is called at the very top of the path of the ball? Do you know what?
I remember hearing about it. I don't remember the exact.
Okay. It is called the vertex. It is called the vertex. And I'm adding that to my picture. That point is the highest point the ball will reach. It will not go any higher than that, unless it actually breaks like gravity or whatever. But we're negligible, whatever, I don't know. The ball's going to come back down. Here's what you need. This is a formula that we are going to put into our notes later today. We're going to put it into our notes later today. But this is the formula to determine the x value of the vertex. Why does that look familiar? Say it again one more time. It's part of the what? Ooh. She says it's part of the quadratic formula. Except it's missing a portion of it. It's missing that plus or minus square root thing. That's got to be just a coincidence, though. It's not a coincidence. It's definitely not a coincidence. There's a reason for that, which I'll talk about a little bit later. But now, let's figure out what that vertex is supposed to be. And that vertex, negative b over 2a, as always, the b and the a are coming directly from this particular equation. The a being negative 16, the b being 40. The c doesn't factor into the vertex. We'll deal with that another time. But here, I got a negative 40 over 2 times negative 16. You need to be careful. I know how you guys operate. I know how you do calculations. I know how you do this junk. Look at this real quick. Look at this. 40 divided by 2 times negative 16. That's not the answer. Okay, maybe I had to put parentheses around it. That is not the answer. That is not it. But a lot of people would do that and be like, oh, negative 320, moving on. No, that is not the answer. In reality, with this problem, you have to evaluate the top and bottom separately. This is really negative 40 over negative 32. That's what the calculation actually is. And if you do it correctly, it should be positive 1.25. Let me go back to the calculator very briefly. If you were going to type it in correctly, it really should have been this. Oh, I forgot the negative on the 40. There we go. Positive 1.25. You got to make sure parentheses around the denominator. Numerator, denominator, all that fun stuff. Wait a minute. What is 1.25? We were dealing with like 3 feet and 19 feet and all that other stuff. Like according to the picture, the ball starts at 3 feet. After 2 seconds, the ball's at 19 feet. What the heck is 1.25? Ah, yes. That is the amount of time. I'm literally just gonna repeat what you just said for the people online. That is the amount of time that it takes for the ball to reach the vertex. Because again, I labeled this formula as the vertex, but yes, it's just the x value of the vertex. It's just the x value of the vertex. And if you remember, the x-axis is measured in time, 1.25 seconds. So how do I then determine the height of the ball at 1.25 seconds? How do I then get? Plug it back in. Where? Yeah. I know it sounds weird, but again, the thing is these steps, these logical steps, people tend to forget it, or people tend to completely bypass it, or they just try to take a guess at it. Yes. Let me do this calculation, and then I'm going to show you something visually, okay? Because this is going to blow your mind. If you did this calculation correctly, actually, let me just type it in right here, ready? Negative 16, 1.25 squared plus 40 times 1.25 plus 3, 28. Ooh. Oh, but we'll answer that question in a moment. I want to go to her question first. 28 feet is the maximum height the ball will reach. The maximum height. Now, let me go back to my picture real quick. Let me zoom in on my picture. Here's the thing. Yes, this is 28 feet. I can't write the number 28. 28 feet. That's 28 feet right up there. That's the highest height that the ball will reach. Now, the thing is, this is at 1.25 seconds. 2 seconds would be after, which means the ball is beginning its descent. It's coming back down.
Yeah, but if you incorporate the average rate of change into it, it wouldn't be able to reach 30.
Oh, you're talking about the 30 question.
Yeah, like using B, but also prove C.
Oh, let me clarify it this way. Number one, I thought you were asking me a different question. I didn't realize that you were also asking me about the 30 feet. But let's just clarify it like this. You cannot answer part C using part B. You can't answer part C using part B. Not possible. Rate of change versus maximum height are 2 completely separate questions. See, because the thing is, the average rate of change is going to be different depending on how you ask the question. For example, for this problem, boom. Here's 2 seconds. Oh, it was right here. Hold on. I got this. There we go. There we go. And there's 0, 3. There's what we did in part B, right? And I drew that picture a little, a thing. Anyway. Average rate of change. Remember I talked about slope. Hey, do you guys remember how slope was defined? How do you define slope? Not the formula, but how do you verbally define slope? I don't know if you remember any of this. It's the steepness of a line. How steep is the line? The more steep a line is, the larger the slope is. Ring any bells? Algebra 1? All right, some yes, some no. Okay, whatever. Now, let's talk about, cover that up. Yeah, let's cover that up. Good. Now, let's say that I changed it to the first 1.25 seconds. Now, 1.25 is where the vertex is. 1.25 is where the vertex is. If I were to go from there up to the vertex, which is now 1.25 comma 28, and this is still 0 comma 3, you probably see it better right here, actually. It's a steeper line. It's a much steeper line, which means if I wanted to find the average rate of change up to the vertex, it's going to be a larger number calculated than I would have for 2 seconds, because for 2 seconds, I'm going to start coming back down. It's a very weird thing. Average rate of change. Let me just see what it would be. You have a calculator, I'm assuming, right? On the computer? Yeah, that's what I'm saying. I was just looking for a Chromebook to be open. So you do this calculation for me. I already know what 28 minus 3 is. And I already know what the bottom is. So do 25 divided by 1.25. 25 divided by 1.25.
20.
Right on the dot? 20 feet per second. So if you only went up to the vertex, the average rate of change would be 20 feet per second. But after that, it starts coming back down and losing height. So now it's only 8 feet per second. Velocity is strange. Anybody in physics? No? What are you all in? Chemistry? Are you going to take physics next year?
No.
Okay, you're nodding yes, though. You're nodding no, though. Okay, that's fine, it's fine. Physics is strange when it comes to velocity and acceleration and things of that nature. You're going to learn that stuff next year, though. I don't want to spoil it too much. But that's mainly what this is kind of getting into. Yes, everything is math. Biology is math, chemistry is math, English is math, history is math. Everything is math. In English, aren't there certain rules and axioms that you have to follow in order to properly write a paper grammatically or to address certain themes? If this is this, and then this is this, or something along those lines? Anything that has rules, anything that has logical rules is mathematical. It is. Logic was one of the original 4 schools of subjects being taught in the Greek schools 2,000 years ago. 2,000 years ago, they called it the quadrivium, and one of those 4 schools was called logic. It was a mathematical art. So was music, so was astronomy, so was computations. It's the only subject that's worth it. I could also give it to you like this. Math is the only subject that is actually worth it because in science, you don't have to be perfect. In history, it's written by the winners, and English is a made-up language. But you can't prove it. 75% of the stuff I say is made up.
Like that 75%, that's also made up.
No, I said 75%.
Which isn't
Not like
exactly
all subjects
75%.
are all made up. There's nothing
Ah.
to say.
Not quite. Here's the thing. I'm going to make a simple statement here. Ready? There's 2 ways to look at math. One of them, you can look at math as it is described by human beings, which is fallible, which is prone to mistake. But the other way to look at mathematics is in its perfect abstract form. Mathematics exists outside of the human mind. If human beings were never born, if human beings never existed on this planet, mathematics would still exist. Human beings just have the ability to recognize it and describe it. You've heard of calculus, correct? Okay. You don't have to know what calculus is, but just know this. Isaac Newton discovered the concept of calculus in the early 1600s. He called it fluxions. But Isaac Newton suffered from an inferiority complex. He didn't like being criticized. So he took his information on fluxions, did not tell anyone, locked it in a drawer, and left it there for 30 years. Nobody saw it until 30 years later, when a mathematician in Europe by the name of Leibniz discovered what he called calculus. Newton looked at it and said, no, this is fluxions. It's just you're using different notation and describing it in a different way, but it's the same thing. 400 years later, both Newton and Leibniz are credited with having discovered calculus independently of each other. Now, how is that possible unless calculus is a concept that exists outside of our minds? And it will exist even if human beings were never on the planet. Finding the glory in the struggle. Go back to my article from the beginning of the school year that answers that question. Remember the article I gave you in the beginning of the year? Finding the glory in the struggle? Yeah, where's the finding the glory in the struggle part of it? Oh, there it is. Go back to your classworks when you have a chance. Open that article and give it a read. That answers your question. Anyway, back to us. My wife used to say that I taught not just mathematics, but I taught a concept known as motivational mathematics. No, the maximum is 28 feet. That answers that question. It will never reach 30. Mathematics answers all questions in the universe. It's just that people are unwilling to see it, even though the truth is in front of them. If human beings were never on this planet, 1 + 1 would still equal 2.
What is calculus?
Calculus is the study of the infinite. It's the idea that, for example, let's say that I walked towards the door, but then I stopped halfway there. So I'm at, let's say, like 32 feet away from the door. I stop halfway, I'm only 16 feet away, correct? I do it again, now I'm 8 feet. I do it again, now I'm 4 feet. Then 2, then 1, then a half, then a fourth, then an eighth, then a 16th, and I keep going. Theoretically, I'll never reach the door. Theoretically. Theoretically, there will always be a positive distance between me and the door. The distance will never reach 0. Fair? But in calculus, you're able to actually cross that gap and go into the infinite number of steps, which you can't do in I shouldn't say real life. You can't do from a logical point of view, but you can do it from an abstract point of view. Anyway, back to this. You can cross out part D. You can cross out part D because I accidentally put the question twice. I just worded it differently. In part D, I said, at what time does the ball reach the maximum height? And what is the maximum height? It's the same question. I just worded it differently. So let's go to the bottom part. If you plan to smash the ball when it falls to a height of 8 feet above the court, how long do you have to prepare for the shot? Now here's the big question of the day. How long do you have to prepare for the shot? What the heck is it even asking? At this point, and I'm going to ballpark this, ready? Let's pretend for a moment that you were taking this as like a test in class, and this was like the last question that you came to. I would wager that more than half of you would just guess and write down a number. Fair? Yeah. I know what you guys are doing. I know exactly what you guys are doing. Oh, but it's at the 26th mile of a marathon is really when the people shine. Just saying. Now you said, oh, I get it. Doesn't matter. Your brain is racing. Your brain is a muscle that you are currently utilizing. And every time you use it, you are exercising that muscle. And the more you exercise that muscle, the stronger it gets. Have you ever been through a class where at the end of it, your brain hurt? Good, because it's a muscle that you haven't used that often, and all of a sudden you're using it. Shut up. What did you said before that, oh, I get it. What did you get about it?
So,
No, he said about this problem.
so ball. Wait, okay. I'm trying to figure it
Ooh, let me go to the picture. Hold on.
out.
He's describing something, and I'm going to the picture. There we go.
So at the vertex, it's at 1.25 or something like that.
1.25 seconds.
1.25 seconds. And it's at 20 feet. So then it goes down to 2 seconds, goes down to 1.9.
19 feet.
You can use those numbers, plug them in, or something like that to figure out how long the time is.
Not exactly. I understand what you're saying, and I understand what you're saying, but unfortunately, the logic is there, but the preciseness is not. If you did it your way, or if you did it your way, you would get close to the answer, but you would not get the exact answer, unfortunately. They're both logical approaches, and I like it. I do like it, but there is a better way we can do this. Let me show you. First, I'm going to draw on my picture. Now, this right here, where the racket is, I did this on purpose. That is 8 feet above the court. That is 8 feet above the court. Let me zoom in. Here we go. My bearded self. That is 8 feet above the court. And our goal is to figure out at what time will it get to me, because that will be the amount of time that I had to prepare to take the shot. Clearly, is it fair to say that the answer is more than 1.25 seconds?
Yes.
Is it fair to say that it's more than 2 seconds?
Yes.
Yeah, because at 2 seconds, the ball is at 19 feet, and I'm waiting for it to come down to 8 feet. So here's what we got to do.
Figure out how long it takes to get to 8.
Would you agree, based on part A, that the height is measured by this equation? I'm going to point to this and say it one more time. I'm going to say it a little bit more emphatically. I'm going to put the emphasis on the wrong syllable. Ready? You ever hear that phrase? The emphasis on the wrong syllable? The emphasis on the wrong syllable? Anyway. At what height are we talking about? We're talking about 8 feet. We're saying how long until the ball reaches a height of 8 feet? How long until the ball reaches a height, look what I'm writing, of 8 feet? How long will answer the question T? How long is a measure of time? How long is measured in seconds for this particular problem? But if you notice, I replaced the H with an 8. Now I'm going to do one more thing. Say it.
We have to just solve it now.
But what do I do first? I got to get one side equal to 0. I'm actually going to subtract the 8. Technically, you could get either side equal to 0. That's up to you. That is completely up to you what side. I forgot the T. You can get whichever side you want equal to 0. But I'm just going to get that side equal to 0 to keep it simple. You have enough tools to solve this. At this point, when you have a quadratic equal to 0, your first goal might be to try and solve it by factoring. I'm just going to bypass that and tell you that this is not factorable. It's not, I'm sorry. Instead, I have to rely on the following. What we've been doing for a couple weeks now. Negative b plus or minus b squared minus 4ac, the whole thing over 2 times a. That's what I got to use. Quadratic formula. Huzzah. Let's calculate the discriminant. The discriminant would be the following. 40 squared minus 4 times negative 16 times negative 5. Oh, that's disgusting. Let's see what the calculator says. Hold on. 40 squared minus 4 times negative 16 times negative 5. Oh, gross. Look at this. I know, right? Ugh, 1280. All right, I guess it is, by the way. Let's just see what I got to do now. Okay, negative b plus or minus the square root of the discriminant, the whole thing over 2 times a. Now, if you notice, remember what we did in part C? What did we calculate in part C? What was the first thing we calculated in part C? The vertex, which we took negative 40 over 2 times negative 16. That's the same thing that we have here, except the only difference is that plus or minus. Adding the square root, subtracting the square root from the top of the fraction. But I'm going to simplify it like this. There we go. It's better to simplify it like that first. Now I'm going to get 2 different answers. I'm going to get an answer with plus the square root, and I'm going to get an answer with minus the square root. I have to do both. Now, I'm going to show you something on my phone. It's going to be amazing. How many people have Androids? Why? You know why my phone's better than yours? This is a Samsung Galaxy 7. Do you know why my phone's better than yours? That's my phone. It's a TI-84 calculator app on my phone that you can only download if you have an Android. It's called Wabbit Emu. My phone's better. You don't have a graphing capability. You don't have a graphing capability. You don't have a way of analyzing statistics in lists. You don't have a way of creating histograms and scatter plots and box and whisker plots using StatPlot. You don't have a way of analyzing high-level statistical hypothesis tests. Huh?
I got 2 cameras on my
Who the heck cares about 2 cameras?
No, I can, at least I can FaceTime.
Why do I need to FaceTime? I can see my wife in real life.
She could be, you could be FaceTiming with her.
Yeah, I know that. I could. Actually, that's a good point. I'm not going to address that. Anyway, back to this. The reason why I show you this is this, because you guys on your Chromebooks have TI-84s, right? Okay, here's the reason. The reason why I show you this. I'm going to show you it on both calculators, okay? This is my phone right here. But I'm going to show it to you. There's a reason. Trust me. This is an 83. This is the 84. Okay? Negative 40 plus the square root. Now, if you notice, look what happened when I did the square root. On my phone calculator, it just did the square root. But when I type it here, look what happens. It opened up a parenthesis. Now, I got to type in 1280. If I type in 1280, it gives me this little arrow button on the left. On the right, it doesn't give me anything. It just has me keep typing. Now, on the right, on my phone, can I get that glare off of there? That's weird. Oh, that's a little better. There we go. There we go. I would have to tap to the right and close it and then divide by negative 32. Whereas on the 83, I would have to close the square root, close the top of the fraction, and then divide by negative 32. I need you to be very careful with how you're doing this. You need to be very careful, because what ends up happening is if you make a mistake and the calculator gives you a number, how many of you ever question the calculator? Well, one person out of the whole class questioning the calculator. Boom, there's one answer. Hey, I thought you said the answer had to be past 2 seconds. Huh? Yeah. You want to know a secret? Check this out. Second, enter. Did you know you could bring everything back and just edit it? Watch. Second, enter. I got to change that plus because remember, it's a plus or minus. It's a plus or minus. You have to do both calculations. Boom. Correct.
Like how would I know that without you being like, oh yeah, this is it.
It's so much easier to get it wrong than get it right. It's almost like someone could say that about life. You get two answers, ladies and gentlemen. You get 0.132 and you get 2.37. 2.37 is the answer. Why did you get that other answer, though? Where did that other answer come from?
That's if you were to hit it backwards.
Nope.
No, wait. It's the other end
What do you mean the other end?
of the
Oh, that's interesting.
trigger.
Ladies and gentlemen,
That's if you were to go.
the ball reaches a height of 8 feet twice.
Oh, what do you think?
No, look, it's at 3 feet right here, right? 8 feet on the way up, and then 8 feet on the way down. That's why it hits it twice.
You're so smart.
I know, I'm a genius.
Yeah. Did you take the test like Miss Betty did?
No, I just declared myself a genius. You know why? You know why? Because it was smarter to do it that way.
Yeah, well,
Ladies and gentlemen, I need you to write something down. Very briefly, I know we only have a few minutes left, but I need you to write something down for me. If you don't already have them out, I'm going to need those notebooks out and open. Yeah, I do.
you're gonna declare yourself a genius. I think you should have some.
You don't even know if my real name's Mr. Markey.
Yeah. I'm not questioning that. I'm questioning your genius.
All right. Ask any teacher. Ask Miss Betty. Say, hey, is Mr. Markey a genius? Do you see her today at all? Okay. If you do, ask her. Just say, hey, is Mr. Markey a genius? See how she reacts.
I'm probably gonna laugh.
I already know how she's going to respond. And it's going to be in my favor. Anyway, back to this. Today is the 21st. As I said very briefly, I'm just calling this quad formula continued. There's just two basic things that I want you to have. If you want to get the x value of the vertex, it is simply this calculation, negative b over 2a. You want to get the y value, you got to plug that thing back in order to get the y value after you get the x value. But that is how you determine what the vertex is. The reason why this was so similar to the quadratic formula was because you could have a quadratic whose vertex is the x-intercept. If you had a quadratic whose vertex was directly on top of the x-axis, that would be when your discriminant is actually equal to 0, which would force the square root to go away, which leaves you with this. Next, I have talked about standard form. Standard form is something that we are used to. Standard form is something that we have seen time and time and time again. But I have two other forms that I need you to see because I need you to recognize that they are quadratics and they will produce a very similar looking result. You have something called vertex form. Now, we've talked about the vertex today. This is vertex form. Now, it's no different. It just looks different. And it has different looking numbers in them. The two letters that you are not as familiar with are H and K, which, believe it or not, would be the actual vertex. You notice how the A is the exact same A? It's because it is. The A is the exact same A. It's just that you don't have B and C now. And then finally, you have something called intercept form. You could take a guess as to what it tells you. It gives you the intercepts, more specifically the x-intercepts. the x-intercepts in this case would be P and Q, but you've seen this before. You just don't know it. Do you know what else this is called? This is called intercept form, but it also has another name. It's also called factored form, because if you just factor it, you have it. We'll talk more about this another time. Bell's going to ring in about 5 seconds. Do not forget the benchmark. And I'm going to sign off. Click, click, boom.